Okay, I just went over to confirm that the lab is doing it from greatest to least. So the default interaction of heaps in the STL is working. Otherwise, you'd have to redefine the heap property inside of C++. And oh yeah, how would you do that? That should be doable through the STL. So you make list. And you could pass a comparator class right here. Look into how that's done, and it would do the comparison based on least to greatest. I didn't want to make this any harder than it had to be, so we'll just stick with the default way of doing it for now.
Doesn't that make it slower?
No. So in the slides, it was going, you want to always get the lowest number. In the lab, you always want to get the highest number.
Oh, okay.
So for this, the default behavior is going to be sufficient. Okay. So now, what was next is we can push more numbers, sure. Now if we want to push a number, vec dot, what was it, push back. What number do we want to push? 60. All right, now, very important, once you push that number, it's not a heap because you just pushed on the back of the vector. So if I were to run it, the 60 is right there, which is not less than, I think it was 11 or 50, yeah. So that's not correct yet. So instead, you can do vec.pushback and then vec dot, I believe it was push heap. And what that's actually doing is sifting up the last number. I think it was it push, yeah, push heap. Oh, you gotta do beginning and ending. All right. And now when we do it, that's 60, or we get a nice big error because I forgot to not make it part of the vector. So now the 60 is up here, and so the 60 is less than, hold on, the 81. So 81 is greater than 40 and 60. So it got sifted up. Perfect. Okay, and then what was the next one? We can pop it? Sure. Pop heap. Is it, I forgot again if it's begin or not. Yep. Vec.begin. Now the reason they wrote it this way is in case you wanted to use a different data structure to represent your heap instead of an array. When does that come up? I do not know. But C++ has this tendency to try and let you do whatever you want, and this is the fallout of it.
So after pop, do we need to heapify then?
No, because it's pop heap, so it's actually removing the top, the greatest element, and then reheaping the whole thing. So it's doing both of that. It's just on pushing, do you have to call two functions?
Is pop heap a void?
Yes. Pop heap removes it, but if you want to get the top, you need to do vector sub 0.
Okay, so, okay.
Yeah, so, yeah. If you want to,
It's not the all-in-one function that we did during the heap lab.
yeah, I know, it's two function calls.
Okay. Wanted to check.
Not a problem. So now if I run it, notice that 104, and then the 104 gets removed, and the 81's promoted. And notice that the 104 is actually at the end.
How does it not get rid of it?
So what actually happened is vector.size needs to be decreased by 1. So you're going to have to keep that in your count. But do keep in mind that that is how a heap actually works when it's an array. It swaps it for the end. So you have to keep internal count of your vector.size, or the actual size of your vector, or your array, or whatever you use. This is interesting. So we can make the heap. We can get the top. We can sort the heap, perform this heap sort. Hey, that would be nice. Is heap will tell you if it's still a heap. Heap until returns an iterator what part of the vector is a heap. Oh, great. Okay, so some comments. Priority queues data structure designed to return orders based on priority. This is used, well, I told you a couple of real life examples, but this is used a lot inside of, what was it? Scheduling, when you're trying to decide which process to run next, or how many time slices a process should get on your system. Something like this is used. Efficiency is usually measured as the sum of the time it takes to add and remove. So simple implementations are O of n, aka the array or the linked list. The binary search tree was O of n on the average. If you had a really complicated or used a balanced binary search tree, you could get log of n. But a heap, which is actually simpler than a balanced binary tree, also gives you log of n, which is why it's usually used. That is not my recommendation, that's the author's. The end. Okay, any questions on a heap before we do the lab? And by heap, I mean the priority queue.
Not really.
Good.